Chapter 21 in Rubin and Babby's 8th edition of Research Methods for Social Work, Quantitative Data Analysis. Slide 2. Chapter 21 gives us an introduction to qualitative data analysis, and in this podcast we will be going over the basics. What we mean by levels of measurement, some data housekeeping best practices, univariate analysis, or analysis when we only have one variable, bivariate analysis, which is two variables informing our analysis, and multivariate tables, which, as you might well guess, involves multiple variables. And finally, a little bit of discussion about the importance of descriptive statistics and your quantitative analysis and its relationship to qualitative research. Slide 3. Now, it might seem a little nonsensical to think of qualitative analysis as being something that converts data into a numerical form, which oftentimes you gather data in a numerical form. And it is true that certain numerical data we don't need to do anything with in order to perform our statistical analysis. However, there is often data that is entirely qualitative, or there is sometimes data that we receive in numbers that we need to clarify as to its meaning so that we can properly analyze them. Slide 4. When we think about analysis in a research sense, we need to be comfortable with the term variable. If nothing varied, there would be no need for research. We could simply explore the phenomenological world and describe it. No analysis would be necessary. But the world isn't that way. The world varies. And since the world varies, we can measure it and all of its components. Researchers have developed a scheme for classifying these various levels of measurement that we use for variables. So we can see that there is even variance within variables. In order to be a variable, a measurement must have two or more attributes, meaning that you can only have a variable that when there is more than one attribute. In the examples we see here, the variable sex consists of two attributes, male and female. Here we can see that in the case of the way we define sex, that including the two attributes male and female creates an exhaustive array of all of the possible attributes of sex. Now say you are doing research on one of those planets that we have seen in Star Trek. If I recall correctly, there is one where there was only females. In that case, the attribute female, in the context of that planet that Captain Kirk visited, would not have a variable we called sex. Since all genders were female on that planet, there would be no way to measure that in any useful research sense. Now, there are different types of attributes. In the variable sex, there's either an either or type of an attribute, but with other variables such as social class, which may have many different attributes that we ascribe to it, upper class, lower class, middle class, etc. Or something like age, where one would see the variance depend on how we define a person's age. Babies are often defined as being so many months old, whereas the rest of us who are many months old, we've developed years as a signifier of age. So while usually age is some sort of an interval variable, level variable, we can describe it in other ways as well. I will use it as an example, the variable age, that is, as we go through and talk about the four main types of levels of measurement: nominal, ordinal, interval, and ratio. Slide 5. Sometimes certain variables such as age can be measured at multiple levels. I would say that the variable age could be assigned to 3 of the 4 levels of measurement shown in the image on the right. Which level would you say age could not be assigned to? 5, 4, 3, 2, 1. Press the magic button and if you guessed ratio, then I like your thinking. I will explain my thinking over the next few slides, and I'll tell you why I think age cannot be assigned as a ratio level of measurement. For the moment, we can see, again on the image at the right, that a nominal level of measure could be something like sex, with attributes of male and female. An ordinal measure are those types of measures that we use when we want to know more about the direction of certain things. In this case, the direction goes from not very important all the way up to most important thing in my life. Interval measures are also directional, but they can be quantified. So for example, IQ could be an ordinal measure, below average intelligence, above average intelligence, above average intelligence. We know where subgenius Bob falls on that scale. But we don't know what is the actual IQ. And finally, ratios are some kind of variable that has direction, has all the attributes of an interval measure, plus has a true zero. Slide 6. Nominal measures. Oftentimes in the literature you will see a nominal measure described as either discrete variables or discrete measures, categorical variables. The important element of a nominal measure is that the attributes need to be mutually exclusive. Say, for example, we have the nominal variable called sex. Typically, we have the terms male and female. But sometimes you will see where people will have a variable titled sex, but they will use the terms woman and man, which is really a gender term, not a sex term. So if sex is conceptualized as either male or female, we could further subcategorize each one of those as male consisting of men and boys, and females consisting of women and girls. And of course there are numerous subcategories of each based on some other kind of status. The important thing is that a nominal measure should only include attributes that are mutually exclusive. While you cannot be a male and a female at the same time, one can be a male and a man at the same time, or a male and a boy at the same time. Depending on how you categorize gender, a male could also be a woman. That's getting a little too complicated. Note, quite often when you are doing research, we will assign numerical codes to nominal measures. Don't make the mistake of trying to statistically analyze nominal measures using its code number as if it were a real number. More will become clear later. Slide 7. The most commonly used ordinal measure in all of social and behavioral research is some sort of version of the Likert scale. Ordinal measures are conceptualized in such a way that their attributes may be rank ordered. So we know that someone who has answered very prejudiced on a questionnaire is going to most likely be more prejudiced than someone who answers either somewhat prejudiced or not at all prejudiced on the same questionnaire, although individual cases may vary. Again, just as is the case with nominal measures, we should never treat the code numbers we assign to categories of ordinal measures as we would real numbers. But we do want to be sure to assign our code numbers in such a way that they correspond with our conception of the variable. It would make no sense at all for us to give the attribute not prejudiced at all a 3, a very prejudiced as a 2, and a somewhat prejudiced as a 4. No, we would assign them numeric codes something like 1, 2, 3, 4, etc., depending on how much variation we have in our measure. Slide 8. Finally, interval and ratio level measures are like ordinal level measures in that they have an order to them. 15 is always lower than 47 or 16, and in both interval and ratio levels of measure, as well as in an ordinal measure, 16 is always going to be between 15 and 47. And in interval and ratio level measures, 16 will always be 1 unit higher than 15 and 31 units lower than 47. So if you think of a ruler, the distance between 16 and 47 will be 31 times greater than the distance between 15 and 16. Whereas when you think back to the ordinal level of measurements, such as what place did someone get in the marathon, we know that the person who came in 16th will be the person who came in immediately after the person who came in 15th and arrived way before number 47. But the amount of time between the time number 15 showed up and the time number 16 showed up may actually be greater than the amount of time between number 16 and number 47. If, for example, number 15 was the last of the really fast runners, and there was a whole pack of runners, numbers 14 through 47, who arrived an hour later, and all together. The only difference between an interval and a ratio level of measure is that ratio measures have true zeros. Now, back to my bonus question from earlier. Why is it that age is okay being a nominal level of measure, but not a ratio level of measure? I think we can all understand why it is an ordinal measure. We know that someone who is 25 is older than a 15-year-old and younger than a 35-year-old. We also know that there is 10 years difference between the 25-year-old and the 15-year-old, and there's also a 10 years difference between the 25-year-old and the 35-year-old person. So whether we call it teenager, young adult, or adult versus 15, 25, 35-year-old, we can see both that it has direction and that the interval between a year of age is going to be the same. Now, it is not a ratio level measure because where is the zero? Can you conceptualize someone as not having an age? Someone either has an age or they don't exist. But on the other hand, we might ask, how the heck can we call age a nominal measure? Well, often we wouldn't, but we often collect a person's age by asking the question, what is the date of your birth? In which case someone might answer October 24th, 1912. Or they may say 10/24/12. But in any case, someone cannot be born on both October 24th, 1912 and October 24th, 2012. Slide 9. When we do coding of our data and convert it into some sort of a numerical system in order to statistically analyze it, it is important that we do so and remain cognizant of what we are investigating. So we can convert age into the number of years someone has been alive, but if we are studying some sort of concept like well-being, we may discover that age as a concept as it relates to well-being is more complex than a simple interval level variable. Sometimes people experience their age differently depending on a host of other factors. Similarly, if we are using income as a variable and we happen to have Bill Gates in our sample, then doing a simple statistical analysis of income based on our sample that would include an outlier such as Bill Gates might not help our investigation. But we can't just go arbitrarily deciding who is poor, lower class, middle class, upper middle class, upper class, rich, very rich, extremely rich. You get my point. By all rights, when somebody decides they are going to assign a certain number to a certain category for the purpose of statistical reasoning, then they should have that reasoning outlined in a codebook or a file on their computer program called Codebook that details that reasoning and hopefully cites studies or other journal articles to support their reasoning. Slide 10. Whether we have well-developed coding schemes based on predetermined categories, or if we develop our coding schemes into something of an open coded fashion such as we talked about in Chapter 20, it is important that we document our thinking at every step of the way regarding the coding that we are using and our rationale for using those codes. Okay, slide 11. Having the codebook cannot be overemphasized in keeping your research organized. In the codebook, you should have a mechanism by which you describe each code and why it is assigned a certain attribute. When does something that is good become better, or when does something slim become fat? And having a codebook will help us keep our thinking straight. When we go to the trouble of describing the attributes of our variables, we'll be less likely to make the mistake of doing things like conceptualizing when being obese has a simple height to weight ratio when it is a much more complex phenomenon. I often hear about various cities being better fans than other cities when it comes to their football teams. Always when I hear about this in the popular media, it has to do with the decibel level at the stadium. Is louder better? What are they basing that on? Those are all the same kinds of questions that you should be asking yourself as you are looking at data and transforming it either from one number to another number or from qualitative data to something that represents that same data only in numeric form. Slide 12. Those of you who work in child protective services understand the importance of things like chains of custody when it comes to evidence. That is a good concept to be relating to when you're thinking about going from the process of having a phenomenon existing out here in the phenomenal world and capturing that phenomenon using whatever measurement instrument that you are using and transposing it into a numeric form so that you can statistically analyze it. Each step of the process needs to be accounted for in order for you to be able to be sure that that observation that you gathered using your measurement instrument was transformed into a number that is representative of it on a consistent basis. That's the theory behind data entry. A lot of the data entry, though, is nuts and bolts techniques. Sometimes when we're doing research, we can enter information directly into a computer. It is relatively easy to create a form using Microsoft Access. And as you ask questions, we can simply type in the answers. We can program those kinds of systems so that we will only put in either male or female in the sex field, that the data entry person can only put in 3-digit number for a person's age, etc. Most of us won't have access to optical scan sheets and they are quickly become something of an archaic technology. Slide 13. Data cleaning is an important part of the entire research process and is one that should not be undervalued. Data cleaning can happen at multiple phases of the data handling process. One should be careful to double-check their data anytime it is transposed from one format to another. So say, for example, that you're doing an oral interview that is in survey format. A form of data cleaning and quality assurance would be to repeat back the answer that you are writing down on the form to your survey respondent to make sure that is what they intended. Next, when you take that pencil and paper survey back to your office to enter it into your Excel spreadsheet or other statistical analysis program, you will want to have some mechanism by which you can check it to assure that you are correctly inputting the data. This may necessitate the need to enter your data 2 or more times to assure its accuracy. Finally, when the data is entered into your computer program, you will want to do a series of steps to check to make sure that your data is accurate. With Excel, it is relatively easy to check our data to be sure that our numbers fall between a certain range or that they were in fact entered as numbered in the first place. In the spring semester, when we are focused more on using Excel and other statistical analysis software, we will revisit data cleaning, and you will no doubt become experts on it at that point. Slide 14. Univariate analysis usually only consists of the simplest analysis. Oftentimes we are simply using some sort of data reduction technique to make the data more manageable to us. If we have one variable, let us say race, usually the most we can do is a count of the numbers of individuals who fall into each race category, some percentages of each race category based on the whole, and maybe some ratios of each race to the other. But it's necessary, since we can't look at a stack of questionnaires and make a lot of sense out of it without that reduction. Slide 15. When we have numeric data that is either interval or ratio, we can do more descriptive statistics on it that will reduce the data into more manageable terms. We can count frequencies. How often does 10 occur? How often does 11 occur? How often does 12 occur, etc. Mostly, we'll be concerned about measures of central tendency, the mean, the median, the mode, or all three. Measures of central tendencies are at the heart of all statistical analysis, in my opinion. And we'll have a lot more on that in the coming semester as well. Slide 16. When we have a single variable to analyze in addition to the measures of central tendency, we also want to get an idea of its dispersion. To what lengths does our data vary from that central tendency? And to accomplish that, we will usually calculate the range of our data, which is simply the highest value and the lowest value and the distance between those two. And the standard deviation, which is the statistical procedure that I will go into more depth in the spring semester. The doing of these basic descriptive statistics is much easier than talking about them. Microsoft Excel for Windows has in its data analysis tool pack a function that will provide the measure of central tendency, the highest value, the lowest value, the range between the highest and lowest values, the variance, the standard deviation, the skew of the distribution, the kurtosis of the distribution, all in one easy click. And we'll get to what all those things mean in the spring semester. Slide 17. Measures of central tendency and dispersion should be used for interval or ratio level variables only and may not be appropriate for all variables. I should put that into all capital letters. Not every year in my quantitative research course do I see it, but I've seen it a lot. Someone will take their category variables such as race, transpose that into a number, and using Excel or other statistical analysis software will give me the average of race. And you wonder why I have gray hair. Now, it is not uncommon, and there is disagreement on it, disagreement among statisticians about the use of measures of central tendency and dispersion for ordinal level measures. Some statisticians will be absolutely fine with using the results of a Likert question as if it were an interval level measure. However, it is important for you as the researcher, if you're doing measures of central tendency on a Likert style question, that you report that you are doing so in a proper format. So instead of saying something like the average score on question 17 was 3.5, you might say something like the typical respondent fell somewhere between approved and strongly approved on the Likert scale. Slide 18. Here's an example of a univariate table formatted in the style one would expect to see in an APA format journal. Here we can see the various categories of age assigned to their percentages on the whole. Slide 19. Bivariate analysis examines the relationship between two variables in order to make some sort of explanation or to build a theory about the relationship between the two variables. So for example, if we want to know whether men and women, and remember men and women are the two subgroups of our variable sex, whether men and women differ in, let's say, their approval or disapproval of a certain bond issue. So sex would be the independent variable and attitudes toward the bond issue would be the dependent variable. The easy part of quantitative analysis of bivariate data is the analysis. Formatting that data into a table takes some head scratching. But if we look at each of these steps and break it down into their parts, it is not going to be that difficult. A good bivariate table should allow the reader to be able to tell which variable you are talking about, i.e. which column or line is associated to which variable, and be able to interpret the table without having to necessarily read the narrative report. Similarly, when you use a table, you don't re-explain it all in the narrative, and the rule of thumb that Rubin and Bavay state in the slide regarding percentage down reading across would drive you crazy without an illustration. So here's that illustration, slide 22. This would be an example of a percentage down read across style of a bivariate table. You can see that 63% of men approve and 37% disapprove, that there are a total of 400 men in the sample and 12 of them did not answer. Compared to women, 75% of whom approved and only 5 did not answer. When writing a report, the narrative portion that explains or points to this table would not include every number on this table. For example, instead of saying that there were 400 men and 400 women, it would probably say that there were 800 respondents equally represented by each gender. Similarly, we would only give either the approval percentage or the disapproval percentage in the written text. We would never say that 63% of the men approved and 37% disapproved. If we decided that not answering the question was as important as whether or not someone approved or disapproved, we would put that percentage into the response category beneath approve and disapprove. Slide 23. The underlying concepts of a multivariate analysis are really no more different than a bivariate analysis. It's just more complex. Looking at the table will provide us with an easier understanding of that, and we will revisit extraneous variables and control variables, etc. in the coming semester. Slide 24. So this is the multivariate table. It's the same table format that we saw bivariate table variable, only that we have added the complexity of the younger versus the older respondents. While we would still say that the sex variable does make a difference in a person's attitude on approval or disapproval, it looks like being younger is a much more of an important aspect that influences approval rating. Slide 25. And finally, descriptive statistics are an important part of any study. That includes qualitative studies. Sometimes that description is limited to simply counting the number of African American respondents versus the number of European respondents, etc. It might mean describing how often children have angry outbursts in the presence of an abusing parent, or it also might mean the percentage of times they have an angry outburst. We often described the range of the age of our participants, the ratio of males to females, or a simple count. The number of years they've been on a job, or their average age, etc., etc. There's lots of numbers that sometimes go into qualitative research. Okay. I would say that's enough for today.